Good afternoon. All right, so we are going to go through the practice test today. Again, I mentioned this yesterday, but I kind of forgot to tell you. The test is not in Respondus, right? And I mentioned it earlier, but it is posted. You can download it whenever you want to, work on it. You know, even if you want to, you can actually print this one out and actually write it on there if you want to, rather than having to write on notebook paper. So however you prefer to do it, it's fine. Just make sure that you get it submitted by midnight tomorrow night, just like you would any other test. But this one you can kind of work at, at your own pace, use whatever resources you want to, notes, books, all that good stuff. And just, again, make sure you get it submitted. The other thing that's due by midnight tomorrow night, though, is the homework for Chapter 6. So if you haven't finished that up yet, just make sure you get that one done. But that's everything that's going to be due prior to the final exam. So once you get everything submitted tomorrow night, then all you got left is the final exam. I'm going to do my best to get the test graded over the weekend so that going into next week, you pretty much know where you stand in the class. And if you have any questions about what you would need on the final for any particular grade or whatever, feel free to let me know. But you should be able to calculate that pretty easily since that'll be the only thing left at that point. Okay. Any questions, comments, concerns before we get started today? Okay, and like I said, even though this is open note, open book for this test, just remember any of this stuff could potentially show up on the final exam, and the final exam is proctored, right? So you won't have open notes and open book for the final. So just make sure, as you're working through it, just make sure you're really understanding how to do these problems so that you would be able to do it, a couple weeks from now without those resources available. Okay. All right. So let's take a look here at number one. We'll just work straight through this, get as far as we can. So we want to find the limit as x approaches 2 from the left of e to the 3 over 2 minus x. Okay, so really all I'm looking for here is, do you understand how to find a limit? And you can see if you look at my solutions that I actually sketched the graph of this one to kind of think through what this limit would be. You could also do a table of values to kind of work your way up to this limit because there's no other good way to really show, any work or algebra to actually find this limit. Okay, so in this case, if you think about the graph, again, you'll have access to Desmos for this one. When you sketch the graph of this, there's actually a vertical asymptote at 2, right? So it's not actually defined there, but the left-hand side of this graph is exponential in nature, but it approaches this asymptote here. And then on the other side, we're going to have this open circle at 2, and it's just going to go off to the right like that. So if we're looking at the limit as x approaches 2 from the left this time, what would that limit be equal to? Infinity, right? Because as you approach 2 from the left, we're approaching that asymptote. It's going up towards positive infinity. And so we would say that that limit is now infinity. And again, if you wanted to do a table of values instead, you would just choose values like 1.9, 1.99, and so on, substitute those in, and just show in this case that those values in your table are getting infinitely larger as you do that, because basically this denominator is going to be approaching 0 as you put those values in there, and then that 3 over 0 or 3 over some really small decimal is going to give us a really large value. E to that really large value is going to approach infinity in that case. Any questions on that one? Like I said, the table is fine, the graph is fine. There is not really any work other than that you would show for this one. So as long as you get that limit and show me something as to how you found it, that's fine. Okay. All right, so now we've got some that we can actually do some work. So let's look at number 2. We want to find the derivative of tangent of 1 plus e to the 2t. All right, so how are we going to start this one if we're looking for our derivative? All right, we can do a u substitution. So what are you going to let u be equal to this time? All right, good. So we'll let it be equal to what's inside there, 1 plus e to the 2t. Right, so when we do this, then we're just saying f of t equals tangent of u. So when we find f prime of t, in terms of u, what's that going to give us? Okay, so what's the derivative of tangent? Secant squared, right? So this is actually going to give us secant squared u, and then we have to multiply that by the derivative of the inside since it is a u substitution, right? A chain rule. Okay, so now we need to know our u prime. So what is u prime going to be equal to this time? All right, so almost, right? The derivative of 1 is 0. The derivative of e to some power is e to that power. But because it's more than just a t this time, don't forget this is kind of a chain rule within itself. And so the derivative of the exponent is going to give us what? 2, right? So we have to remember to multiply by 2 this time. So our u prime is really 2e to the 2t. So if that had just been e to the t, then it would have just been e to the t, right? But in this case, because it's a 2t, we have to make sure we multiply by that derivative, which is a 2. Any questions about how I got that derivative? All right, so now we can just substitute everything back in over here. We have f prime of t equals secant squared. Plug in your u value, 1 plus e to the 2t times u prime, which is 2e to the 2t. And really, the only other thing, if you wanted to move the 2e to the 2t to the front, you could, but there's no distributing you could do, no simplifying you could do. So even if you stop right there, that's perfectly fine also. Any questions on that one now? All right, so number 3, if we want to find the derivative this time, what could we do first here? All right, good. Let's change that square root to a 1/2 power. I'm going to write this as y equals 1 plus x e to the negative 2x raised to the 1/2. Okay, and then we can do what? Okay, good. Let u be equal to all that stuff inside there. So we'll do 1 plus x e to the negative 2x. So now this just becomes u to the 1/2. All right, so then what are we going to do? All right, if we find our u prime, how are we going to find u prime this time? right? So it kind of involves a chain rule, right? Because we got a negative 2x in the exponent there. But overall, this is really going to be what rule? It's a product rule, right? Okay, so it's a product rule mainly, and then within that product rule, there is going to be a chain. Okay, so I'm going to think about, the derivative of 1 is just 0, so we can kind of ignore that. So I'm really just looking at letting f be equal to x, and the g function then is e to the negative 2x. So if we find those two derivatives now, derivative of x we all know is 1. What's the derivative of e to the negative 2x going to give us? Right, so we'll have e to the negative 2x times negative 2. So negative 2 e to the negative 2x. All right, so then at that point, we can use our product rule and just plug those back in, right? So we'll start in this case with our f function. So we'll have x times g prime, which is negative 2, excuse me, e to the negative 2x plus e to the negative 2x times 1. All right, now that we have all of that, now we can just go back over here, find our derivative in terms of u. So what's y prime going to be in terms of u this time? Good. 1/2 u to the negative 1/2. Because it's a chain rule, right? Don't forget we still need the u prime here, so times u prime. Now we can plug everything back in. So y prime equals 1/2 times 1 plus x e to the negative 2x to the negative 1/2 times u prime, which gives us, I'm going to write this as negative 2x, right? So we could say this is negative 2x e to the negative 2x plus e to the negative 2x there. So negative 2x e to the negative 2x plus e to the negative 2x. Excuse me. All right. And really the only other thing, that you might want to do in this case, you could move the negative exponent down to the denominator and then put all this other stuff up in the numerator. If you wanted to write this as y prime equals negative 2x e to the negative 2x plus e to the negative 2x over 2 times 1 plus x e to the negative 2x to the 1/2, or change that to a square root. You could also factor out the e to the negative 2x and move it to the bottom if you really wanted to, right? But any of those forms there, as long as you use the u substitution, do a chain rule, and you get all those pieces in there, right? That's the main thing I'm looking for. Any questions on that one now? Okay, and I'll just tell you on this test, take your time, right? That's why I didn't make this a time test, right? I know, there's only going to be a couple of questions from each unit on the final exam, which is why that one I feel like I can make it timed. But for this one, because some of these, they take some time, there's a lot of places you can make little careless errors and things, right? So you've got a couple of days to work on it. Take your time, check your answers, right? Don't rush through it, okay? All right, number 4. So we've got an integral of 1 plus e to the x squared all over e to the x dx. So what's the first thing we might want to try here? Um, so split it up into two fractions. So what would your two fractions look like if you did that? So 1 over e to the x, e to the x squared. Okay, be careful here. If we actually simplify the numerator first, what is that going to actually become? So if you did 1 plus e to the x all squared, what would that look like? There we go, right? So we would have to multiply this by itself, right, and use FOIL here. So if you want to see the work for what that would give us, we would do 1 times 1 is 1. Outer terms would give us plus e to the x. Inner terms would give us another e to the x. And then down here now we would add those exponents, so that would be e to the 2x. Combined like terms, we get 1 plus 2 e to the x plus e to the 2x. So that's what our numerator actually is this time, is 1 plus 2 e to the x plus e to the 2x. And all of that now is over e to the x. Okay, now we can do what Brandon was saying before, right? And actually split up the fractions. Okay, so this time that we're going to actually end up with 3 different fractions when we do that. So we'll have 1 over e to the x plus 2e to the x over e to the x plus e to the 2x over e to the x. And then always simplify what you can. So how could I write the 1 over e to the x now? Good. So we'll write this as e to the negative x, because that'll make the antiderivative easier, plus, what's that next term going to give us? That's just a 2 now. Good. And then finally, the last term is going to be what? Good. E to the x, because in this case, when we divide, we subtract exponents. 2x minus x gives us e to the x. Now we can go through and find the antiderivative for each one of these terms. So if we look at e to the negative x, what's the antiderivative for e to the negative x going to give us? What's the antiderivative of e to the x? Let's start with that. Okay. So You don't want to actually do like a power rule or anything on this, right? Because this isn't like to some power. So, and you don't need to do, so that would be the same thing, right? We don't want to do a power rule because you only do a power rule if it's x raised to some power. In this case, this is e raised to the x power or the negative x power in this case. So really, the antiderivative of e to the x is e to the x. So the antiderivative of e to the negative x, we just need an extra negative in there to take care of the chain rule piece. This is just going to be a negative e to the negative x. Just remember, if I take the derivative of that now, I'm going to get e to the negative x times the negative 1, which would cancel out the negative and give us e to the negative x. So e to the x and e to the negative x, those are really easy ones to do derivatives and antiderivatives of, right? Because the derivative and antiderivative are going to be the same, right? Regardless of which direction you're working. Any questions on how I got that first term now? All right. What about the second term? Antiderivative of 2? So the derivative of 2 would be nothing, but the antiderivative would be 2x. Right, and then the antiderivative of e to the x would be what? Just e to the x. Good. And this is just a general antiderivative this time, so we have to remember what? Plus c. So this would be our final answer for that one now. So again, always look for ways to simplify if you have a fraction up front, because if you can do that, right, then it avoids u substitution. And in this case, the u substitution isn't going to work anyway, because you'd have to let u be equal to the numerator. That's never going to give us that e to the x in the denominator that we want this time. So simplify your fraction first, and then just take your antiderivative of each piece of that once you simplify it. Any questions on that one now? All right. Number 5. So we got e to the sine theta times cosine theta d theta. We want to find the antiderivative or the integral for that one. So what are we going to do first this time? Okay, good. This time we need to do a u substitution, right? So we're going to let u be equal to the exponent on the e. So we'll say u equals sine theta. And so that means I can rewrite this now as e to the u. And so I'm still missing what? Good. The cosine theta and the d theta, right? That's what I still need to replace here. Well, if I take my du dx over here now, what's the derivative of sine theta going to give us? It's going to be cosine theta. Okay, sorry, this should be d theta. Okay, so du d theta. And so now we know we want cosine theta, d theta together, so I'm going to move the d theta to the other side. So I have du equals cosine theta, d theta. That's what I'm trying to replace, so it just becomes du this time. All right, so now if we integrate that, what are we going to get? Good, just e to the u. And again, because it's indefinite, right, we do need the plus c. And then our last step, we just plug the u value back in. We're just going to get e to the sine theta plus c. That is our answer. So in general, right, if you ever have e to some power inside of an integral like that, let the exponent on your e be your u value. See if that then gives you, once you take the derivative, what you need left over. And then it should simplify down to something nice that you can just find the antiderivative pretty easy. Any questions on that one now? All right, number 6. So we're looking in this case for intervals of increase, decrease, our concavity, and any points of inflection, right? So only those 3 things here. It doesn't ask for mins and maxes, even though we would be able to find them once we know increase and decrease. What would we want to do first in this case then if we're looking for those 3 things? Good, we need our first derivative, right? So let's go ahead and look for that. So what are we going to have to use this time to find the first derivative? Quotient rule, good. So let's go ahead and think about all those pieces, right? So I'll do f is the numerator, e to the x. G then is the denominator, x squared. So what's f prime going to give us then? E to the x, good. And our g prime is 2x, good. So now if we look for first derivative, don't forget, always start with g in this case. So it's going to be x squared times e to the x minus e to the x times 2x all over x squared squared. Any questions about how I got that now? Now let's go ahead and simplify what we've got before we find our critical numbers here. So what could I do with that numerator? Yeah, we can factor out the e to the x, right? So there's going to be e to the x. Is there anything else I could factor out this time? Yeah, there's an x in common also, right? So I'm going to actually factor out x e to the x. That'll leave us with x minus 2 then, if I do that. And then down here, this is going to become x to the 4th power. Okay, so now that we've done our factoring, now what can we do? Okay, good. Find our critical numbers, set every factor equal to 0, including the denominator, because we need to know where this thing's undefined, right? Now, if we do that, that's going to give us x equals 0 for that first factor, e to the x equals 0 for the second one, x minus 2 equals 0, and the denominator will be x to the 4th equals 0. So the first one's good, x equals 0. E to the x equals 0, what would that give us? Does not exist, right? So there's no solution to that one, right? So we're not going to get any critical numbers here, so no solution. The next one's going to give us what? Good, x equals 2. And then down here we would get 0 again, right? So now we really only have 0 and 2 as the 2 critical numbers we need to worry about. So we'll do our number line. 0 and 2. This is our first derivative number line. All right, so now let's test some values this time. Now, if we start plugging in values, what do you want to test first? -1 works. Right, so again, we're plugging that into the first derivative. I'm going to do it in the factored form right here. So I have -1 times e to the -1 times -1 minus 2 all over -1 to the 4th. Now, the -1 to the 4th power, always positive, right? Because anything to an even power like that's going to be positive. Then if we look at our numerator, -1 is a negative. E to the -1, is that going to be positive or negative? It's positive, right? That's just 1 over e, and that's still a positive value, even though it's fraction. Okay, so that's positive. And then -1 minus 2 is going to be a negative, right? So overall, then, that interval is going to be what? Should be positive. Good. All right, now let's choose something between 0 and 2. So what do you want to test there? +1 works. So this time we've got 1 times e to the 1, 1 minus 2, all over 1 to the 4th. Right, so again, we already said anything to the 4th power is definitely positive in the denominator. 1 this time is positive. E to the 1st, definitely positive. 1 minus 2, though, is going to be a negative. So overall, this one's going to be what? It's going to be negative. Good. All right. Finally, we need something bigger than 2. 3 is good. 3 times e to the 3rd. 3 minus 2, all over 3 to the 4th. And hopefully you can see in this case, everything is going to come out positive here. And that means that this is going to be a positive. So any questions up to that point about our number line, the derivative, any of that stuff? All right, so now part A just asks for increase and decrease. So let's think about those intervals now. So where is this going to be increasing this time? Okay, so from -infinity to 0, good. And then from 2 to infinity. And then that means that our decreasing is going to be from what interval? Just 0 to 2. Good. Any questions about how we got those? All right. So I'm going to erase this work right here. So what's the next thing we need to do then? Yeah, now we need the second derivative, right? So if we look for the second derivative, what are we going to have to do to find our second derivative this time? And I'm going to try to make this a little easier. Since we have that common factor of x on top and bottom, this is really just e to the x times x minus 2 all over x cubed. And if you had simplified it up front, right, it wouldn't lose any information, right, because we still have x equals 0 as a critical number in either case. So if you want to simplify it that way, that's fine. This will make the second derivative a little easier. And so what are we going to have to do to find the second derivative this time? Okay, good. It's a quotient rule, and within the quotient rule, there's going to be a product, right? So think about our f function as the numerator. That's e to the x times x minus 2. G function is just the denominator. So then when we find the derivative of f, that alone is a product rule now. So if you need to write it out, you can, right, as just f is e to the x, g is x minus 2. In this case, what's our f prime going to be? E to the x, and what's our g prime? 1, good. So you might be able to do this, without actually writing all that out, but if you need it, please feel free to write it out. So then we start with f, so we have e to the x times g prime, which is 1, plus g, which is x minus 2, times f prime, which is e to the x. And then our g prime over here now is just what? Three x squared. Good. All right, so now we can use our quotient rule, right? So we're looking for f double prime. And so when we do that, you want to simplify this. This is e to the x plus e to the x times x minus 2, right? So now we start with g, though. So that's going to be x cubed times e to the x plus e to the x times x minus 2 minus, and then we're going to do the f, which is e to the x times x minus 2 times 3x squared. Sorry about that. All over. And then this is going to be x cubed all squared. All right, now we probably want to distribute some of this stuff out, look for common terms, like terms that we can combine, and then look for any common factors, right? So we do this now. I'm going to start inside this big set of parentheses up here in the numerator. I'm just going to keep my x cubed for now. It's going to give us e to the x. Distribute here, we get plus x e to the x minus 2e to the x. And if we distribute this stuff out down here now, that's going to give us minus 3x squared e to the, that'd be x cubed, sorry, 3x cubed e to the x. And then plus 6x squared e to the x. Right, so I just multiply the 3x squared times the x and the minus 2, and then multiply by the e to the x. So that's how I got 3x cubed e to the x, and then minus, it became a plus, right? 6x squared e to the x. All right, now from there, we combine like terms in this first set of parentheses. We have an e to the x, a negative 2e to the x. So we're going to have negative e to the x plus x e to the x. And then down here now, minus 3x cubed e to the x plus 6x squared e to the x. And then finally, we can distribute the x cubed here. So we get negative x cubed e to the x plus x to the fourth e to the x minus 3x cubed e to the x plus 6x squared e to the x. And I still actually have like terms there. And so we can combine the x cubed e to the x terms at that point. And so we end up with x to the fourth e to the x minus 4x cubed e to the x 6x squared e to the x. All right. Let me pause there, right? Because I did a lot of steps where I was just distributing, combining like terms, that kind of stuff. Okay, so if I lost anybody, are there any questions on how I got to that point? All right. Now, once we get to there, what can we do? Okay, good. So we have a common factor of x squared and e to the x. So we can factor that out now. Take out the x squared and the e to the x. It's going to leave us with x squared minus 4x and a plus 6 all over x to the 6th. And then just like the first derivative, since we have those x's in common top and bottom, we can cancel those out. So if you want to simplify this down, it would just be e to the x times x squared minus 4x plus 6. And then we're left with x to the 4th in the denominator. All right, now that we've factored and simplified, then we can do what? Good. Set each factor equal to 0. Okay, and notice here, right, the x squared minus 4x plus 6 is not going to factor. So if you set each factor equal to 0, e to the x equals 0. We know that doesn't exist, right? There's no solutions to that. If I set this thing equal to 0, my only option would be quadratic formula, but real quick, put this in Desmos just to show you. Switch over to that. Let me change my window so it's a little clearer. There's what that looks like, right? So what would be the solutions to that quadratic this time? There is no solution, right? Not in terms of real numbers anyway. Those solutions would be imaginary. So that doesn't exist either. Okay, so by just looking at the graph here, we can see that the x squared minus 4x plus 6 is not going to give us any critical numbers. And so then look at the last piece. And so that's just the x to the 4th equals 0, which is just going to give us x equals 0. So that's the only place we really need to test then to see if our concavity switches, right? We'll do our second derivative number line. Put 0 on there. All right, so what value do you want to test in that first interval then? Okay, -1's good. And I know I'm running into number 7 down here, but I'm going to plug that in to my second derivative. I'm going to do that factored form down at the bottom there. So e to the -1 And we'll have negative 1 squared minus 4 times negative 1 plus 6 all over negative 1 to the 4th. And we know that denominator is positive. E to the negative 1, we already said that's going to be 1 over E, which is a positive. So now it's just a matter of figuring out this inside piece here. Negative 1 squared is 1. That's going to become a plus 4 and a plus 6. So is that going to be positive or negative? It's going to be positive, right? And so all three of these positives then overall make that a positive. And so then we just need something on the other side. So I'll just go with positive 1. So this time we've got e to the 1 squared minus 4 times 1 plus 6 all over 1 to the 4th. Again, denominator is positive. E to the 1st is positive. 1 squared is 1 minus 4 plus 6. Is that going to be positive or negative? It's going to be positive. And if you remember the graph, right, the graph was always above the x-axis. So no matter what I put in there, it should come out positive. So overall, this is going to be positive now. Okay. Now, what does that tell us then? Okay, no points of inflection, right? So we definitely don't have any points of inflection. And then what about concavity then? Always concave up, but we do need to split it, right? Because if you think back to the original function, it would be undefined at 0 because of that x in the denominator. So it's just going to be from negative infinity to 0 and from 0 to infinity. Okay. So, I mean, honestly, the hardest part of that one is that second derivative, right? Just because of how many terms there are and everything. But just simplify it down. Think about your critical numbers there. Generate your number line. And in this case, it's always positive, so it's always concave up. Any questions on that one now? All right. I'm going to start the next one. If you need to drop out, because I know people, have other places to be and stuff, that's fine. I'm going to at least try to get through this next one though. And then if you do have any questions, right, my solutions are posted. If you need to send me an email or something in the meantime, let me know, and I'll be happy to explain anything I've got there. All right, so this one right here, we've got h of x equals natural log of x plus the square root of x squared minus 1. So if we're looking for h prime, right, how are we going to do that? All right, so let's let u be equal to everything inside there. So that's u equals x plus, I'm going to go ahead and write this as x squared minus 1 to the 1/2, because I know that's going to be helpful for finding that derivative. So that means that we're really just finding the derivative of natural log of u, right? What's the derivative for natural log of u? 1 over u, because it's a chain rule, times u prime. Okay? All right, so we need to find our derivative over here. So first term here, derivative of x is going to give us what? Just 1, right? So that first term is just 1. plus, and so now we're going to have a power rule combined with a chain rule here, right? So I'm going to bring down the 1/2, keep everything inside, subtract 1 from my exponent, and then what's the derivative of the inside going to give us this time? 2x, right? So I just need to make sure I multiply by a 2x this time. And then however you want to clean that up is fine. We got u prime equals 1 plus the 1/2 and the 2 are going to become 1, right? So then that gives us x over x squared minus 1 to the positive 1/2 if we move that to the denominator. All right, so now we should have everything we need to just plug everything in here. So now we've got h prime of x, 1 over our u value, which is x plus x squared minus 1 to the 1/2, times 1 plus x over x squared minus 1 to the 1/2. And honestly, if you stop right there, I'm content with that answer. If you want to try to, combine some stuff, you can. This actually simplifies down pretty nicely if you go far enough to just give you 1 over the square root of x squared minus 1. But again, if you get to here, no negative exponents or anything, I'm good with that answer there. Okay. Any questions on that one? All right. So like I said, we'll stop there. There are a few more, right? So just make sure, take a look at my solutions and then email me if you have any questions about those. But again, the test is posted. You've got until midnight tomorrow night to do it. Work at it at your own pace because it's not timed this time. There's no proctoring. Use your notes, use your book, whatever you need to. But again, take your time on this one because these problems take a little time. And like I said, there's a lot of little places to make errors, right? So just make sure you go back and kind of check yourself, okay? But again, let me know if you've got questions. Don't forget the homework that's due tomorrow night at midnight also. Other than that, have a great weekend, and I will see you all on Monday.